Hi everyone. In today's challenge, we are going to solve this problem. The problem name is single number 2 and the problem number is 137. Alright guys, so as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, Python and JavaScript programming language. Fine guys, now let's see what this problem says, right? So problem says given an integer array nums where every element appear three times except for one, which appear exactly one. So guys, first of all, we are given one integer array as input. So we can select integer array. This is only the input we are given. Now in this array, we are going to have some values, right? Some integer values. So they told us that all the values means all the distinct values. Let's say there are some values 2, 4, 2, 6, 2, 4 and 4, right? So they told us that in the array every number, every element is going to repeat exactly three times, right? So here you can see 2 is repeating three times, right? Here and here. 4 is also repeating a three times. So every number is going to repeat three times in this array, but there is going to be one number which is going to repeat only one time. That is always going to be exactly one, right? So they in this array there is going to be exactly one number, only one number which is going to repeat only one time, not three times, but rest of the number is going to repeat three times. So in this example as well, you can see 2 is repeating a three time, right? You can see here, here and here. 4 is also repeating a three time. But there is a 6 number which is not repeating a three time, which is repeating only one time, right? So we have to just find out that number. You can see find the single element and return it. So we have to find this number and we have to return it. So this is the only main goal we have to do in this problem. What we have to do, we have to find a number which is repeating only one time in our integer input array. Fine, right? Now the next line is you must implement a solution with a linear time complexity, linear runtime complexity, and use only constant access space. So guys, now we have to make an algorithm which should work in big of n time complexity and big of one space complexity. Fine, that's cool. We are gonna make like algorithm like this only. So let's move. Let's see first of all example one and example two, how we are getting this answer. So guys, in the example one, you can see we have 2, 2, 3, 2, right? This integer array. So here we can say 3 is the only number which is repeating only one time in this input. We can say the num array, right? 3 is only the number which is repeating only one time. And example 2 also you can see 99 is the only number which is repeating one time. Rest 0 is also repeating three times, 1 is also repeating three times, but 99 is repeating only one time. So we have to return that number. I hope it makes sense, right? So I hope you understood the problem statement. What we have to do, we have to just find a number which is repeating only one time in our input array. So now let's move to the logic part and see how we can implement this, or we can say how we can write a code which can solve this particular problem, right? So let me write a logic part. Fine. So what we are going to do, guys, first of all, let's take this example one, we can say numbers array. So we have 2, 2, 3 and 2. So for now, I'm not going to tell about the code, but for now, just try to understand what we are doing, right? Here it is a logic part, right? So what I'm going to do, I'm going to convert all these numbers into a binary representation, right? Fine. So for 2, we have 1, 0 as a binary representation. For again 2, we are going to write 1, 0. For 3, we have 1, 1. For 2, we have 1, 0, right? So this is nothing but binary representation, right? So now what we are going to do for each, we can say index, or we can say each ith number, right? So you can see on this particular level, right? On this, we have only one set bit, right? Now if you focus here, it should not be the case, isn't it? It should not be the case because here the number of set bit or number of ones should be the multiple of 3 only, right? If the number is repeating, right? So there must be a number which is repeating only one time and having a set bit at this 0 index as well, right? What I mean by simple thing, guys, the number of 1 should be multiple of 3, right? So here you can see, guys, the number of ones is coming, number of set it is coming, not a multiple of 3, it is only 1, right? So 1 more 3 is nothing but 1 only, so we are going to write nothing but 1 here. Why I'm doing this, guys? Because this one is going to tell us that the number which is repeating only one time is have a set bit at this particular 0th index, right? So we have write 1. Now the first index, we are going to find again the number of ones. The number of 1 is nothing but 4. Again a issue, guys, because number of 1 should not be the, because it should be the multiple of 3, right? It should not be like 4 or we can say 5. It should be the multiple of 3 only. Either it could be 3, it could be 0, it could be 6, it could be 9, right? But here again I'm getting 4, so I'm going to say 4 more 3, which is 1, right? Means there is also, we can say a number which is repeating only one time, that also have a set bit on this first index. So we are going to write nothing but here as well 1, right? So we're going to say fine, there is no more, we can say index present. So we're going to say fine. Here just calculate this particular thing into a decimal, right? So 1, 1 is nothing but we can say 3. So we are going to return nothing but answer 3 only. I hope it makes sense, right? But this was a very small, we can say, example. So let's remove this one and let's take a bigger one, right? So that you can have a better understanding what I mean here. So what I'm gonna do, guys, here I'm gonna say we have a nums array 4, 4, 4. Let's write a 4, 5, 2, 4, 5, 2, and again 4, 5, 2, and the last one is nothing but we can say 7, right? Or let's give it a name 6, right? Fine. So this is our array we have right now. Now we have to find a number which is coming only one time. So here we know that by seeing the 6 is coming, right? But how we are gonna do? We are gonna say convert first of all this into a binary representation. So we can say, guys, 4 is nothing but we can say 100. So let me write 100. 5 is also we can say 101. 2 is 10, right? Again 4 is 100. 5 is 101. 2 is 10, right? Again 4 is 100. 5 is 101. 2 is 10, and 6 is nothing but we can say 110, right? So guys, now we can see that we have this binary representation, right? Now first of all we are going to see on 0th index, find out how many ones means how many set bits are present. So 1, 2, 3, there is 3 present, that means fine, this is cool, right? We are going to write nothing but 0 only here, just because we have a multiple of 3. That means the number which is coming only one time does not have a set bit at 0th index. That is makes sense, right? Now the at first index, let's see. So here we are getting 1, 2, 3. Here we are getting 4 set bit, but it should not be the case. It should be multiple of 3, right? That means the number which is coming only one time have a set bit at the first index. So means we are going to write 1 because it has a set bit at the first index. Now again 1, 1, 2, 4, 6, and it's coming 7 time, right? I hope it makes sense. It's coming 7 time. Again, it's not a multiple of we can say 3. So that means the number which is coming only one time have a set bit at second index as well. So we are going to write nothing but 1. So now if we convert into decimal, we are getting 6. So 6 is nothing but our answer. So we can say our answer. I hope this makes sense, right? So with this, I hope you understood the logic part. Now the question comes, how we are gonna do all these things? We are gonna convert all the numbers into first of all binary representation. Then we are gonna do like this particular thing. No, this is just for make you understanding this how our logic gonna look like, right? Now for coding part, let's see how we are gonna do this. We are gonna just say, as we know that we are going from 0 index to 1, 2, 3, we'll go till 31 index, right? Why? If you will see, let me open this particular browser as well. Let me show you the constraint. So guys, in this browser must see the always see the constraint also. So here you can see 2 raised to the 31 minus 1. This number will never be greater than 2 raised to the 31, right? It will never be greater than or equal to that. It will always be less than 2 raised to the 31. So what we are going to do, guys, here we are going to say, okay, so we are going to use 0, 1, 2, 3, so on up to 31, not more than that. So we are going to use a loop which is going to run till 31, right? So for that we can say for int I is equal to 0, I less than 32, because it's going to run till 31, I plus plus. Right, we can use this particular thing, right? I hope it makes sense, right? So you're going to traverse only on this particular 31 index till 31 index, right? On each index, we are going to calculate the total number of set width, right? That's what we were doing, right? On 0 index we found 3, on first index we found 4, on second index we found 7. So on each index we just finding a total number of set width. So for that, what we can do, we can say here in this loop, just say for int value in this our given array, let's say arr, or we can say nums, right? So now we are going to traverse on this nums array, and here we are going to check, just find out the set width. So it's going to traverse all these array on this 0 index, and it's going to find out the total set widths, and here we are going to calculate which is getting a 1, right? So here if this will traverse over this whole array, and here if you'll find, okay, 5 has a set width at this particular index, so just count that one, right? So on each index we are just going to count the set width, and we are going to check if that set width is multiple of 3, then cool. If it is not, then add, you can say add a 1 on that particular index, right? So that's what we are going to do, and that will solve easily our problem, right? So let's move to the implementation part, and let's see how we can implement it, right? And this gonna be really easy, right? So guys, I'm first of all with Python. So here first of all what I'm going to do, I'm going to say find out, first of all say result which we are going to return, right? And here we are going to say for value, or we can say for I in range of 32, right? 32, right? Fine. And each index we are going to calculate the total number of set bit. So first of all, let me make a number. So I'm saying that this number is nothing but 1 raised to power 1 into multiply by 2 into I, 2 raised to power I, right? Why I'm doing this? Just because I'm going to find out that particular index, right? So how can I get a set bit? So I can simply get if number mode, not mode, if number and that particular value is going to be is equal to not equal to 0, that means that is a set bit, right? So we're going to do like this only. We're going to say for value in nums array, traverse over this nums array. Now on each index we are going to traverse over the nums array, and on each value of this nums array we are going to say if value we can say AND operator of this num. If this is not equal to 0, that means this has a set bit, right? And if this has a set bit, so we are going to increment our count. Count plus equal to 1. And we have to define count as well. So we are going to say count is 0. Right. Now this we are going to come out from this for loop. We are going to say, just tell me the count is multiple of 3 or not. If count mode, we can say 3 is equal to 0. If it is equal to 0, then it's fine. But if it is not equal to 0 for this particular index, so we are going to say add a 1 into this, but add this particular index. So we can say result is going to be nothing but result or operator result is equal to this particular num. So this is nothing but going to add 1 at that particular index, right? Fine. And we are going to come out this for loops for 30, and here we are going to return our result. But you will find here one exception in just only in Python programming language, not in C++, Java and JavaScript, only in Python, right? So you can see this is working fine. But if I took any other test case which have a negative value, so it's not gonna work fine, right? It's gonna give a wrong answer. That is because whenever we use this shift operator, what it's gonna do, it's gonna do a arithmetic shift. But we want a logical shift, which C++, JavaScript and Java do, right? So for that, what we can do here, only in this programming language, we can say if result is greater than or equal to 2 raised to power 31. Right? If it is greater than or equal to 2 raised to power 31, so we can say result minus equal to, if it is greater than 2 raised to power 31, so we can say minus equal to 1 to 2 raised to power 30. Note this line. Now if we run this code, see whether it's working fine or not. Okay, we have done. Okay, we are using a curly braces. We have to use a Python, right? Fine. Now let's see whether it's working fine or not. So you can see, guys, both the test case. So earlier it was also was, but now if we submit this code, it will gonna submit as well, right? Because we are using now this exception as well. So you can see that it's successfully got submitted. Now let's move to the next programming language, which is nothing but C++. So let's move to quickly C++. Here I'm gonna say int result is 0. Int result is 0. So which is we are going to return 4 int I is equal to 0, I less than 32, I plus plus, and here on each index, first of all we are going to get a number is nothing but we can say I 2 raised to power this particular I, and we are going to check if number, and first of all let me traverse over this nums array for value, this nums we are going to say if number and this value is we can say not equal to 0, that means that is a set bit, so count this particular set bit, and we have to say count as well, which is initially 0. Fine. Now once this is done, we are going to say if our count mode 2 is not equal to 0, right? So that means this is we can say our number which is coming only one time have a set bit at that particular index. So add that index in our result. Result or operator is equal to this particular, we can say or operator, right? So we can say equal to this, and here we can say this particular number. Fine. After that we are going to say come out this for loop and return your result. Nothing else. Let's run this code and see whether it's working fine or not. So it should work, right? You can see both the test case pass. So let's try to submit this code as well, and I hope it should also submit. So you guys can see that we have successfully submitted with C++ as well. Right, now let's move to the next programming language, which is nothing but Java. Quickly say result is 0, and here we are going to say 4 int I is equal to 0, I less than 32, I plus plus, and we can say if, not if, we can say first of all find a number. So int number is going to be nothing but 1. We have to 2 raised to power I, and after that we are going to say browse over the array for value nums in a value mode, not mode and operator, value and num is not equal to 0, that means this is set bit. So we are going to say count plus plus, and we have to use a count variable again. Int count is equal to 0. So if our count is more than, not modulus of 3, means if count is not multiple of 3, is not equal to 3, right? So we are going to say nothing but add result or operator is equal to this number, and after that we are going to return the word result, right? Let's run this code and see whether it's working fine or not. So guys, you can see we got an error that is nothing but value and num, right? So we have to use a one extra bracket over here to make it clear that we are using a binary operator. Fine. You can see, guys, both the test case passed. So let's try to submit this code as well. Okay. So you can see, guys, it also got successfully submitted. Now let's move to the last programming language, which is nothing but JavaScript. Fine. And in the JavaScript, what we are going to do, we are going to say fine. First of all, say let result is 0, and there we are going to say for let I is equal to 0, I less than 32, I plus plus. Here we are going to say okay, just first of all find a number, let number is equal to nothing but 1 I, and after that we're going to say let count which is initially 0, fine, and here we're going to say num store, we can say what we can say for each, and here we can pass a functions which is taking a value, and here we can say fine if value and this num is not equal to 0, that means this is a set bit, so this is a count plus plus, fine, and after that we can say if this count is not multiple of 3, then you can say result should be equal to or result or equal to nums, right? That means we are adding a set bit over there as well, fine, and after that we can say in this for loop we can say return our return result, right? Now let's run this code and see whether it's working fine or no, and I hope guys it should also work, right? You can see both the test case passed, so let's try to submit this code as well. So by this we are going to successfully submit with Python, C++, Java, and we can say JavaScript programming language. Fine. So guys, we have successfully implemented. We have also seen the problem understanding part. We have also seen the logic part and the time complexity. Let's see. So guys, time complexity is nothing but we could say the time complexity is big of n into 32, right? So 32 is a constant. So we are going to say it is big of n only, and space is just only big of 1 only, right? We are using a result variable, num variable, and count variable, 3 variable, right? So this is also big of 1. We are not using any array or anything, hash map, anything else. So we can say time complexity big of n, linear, and space complexity is constant, means big of 1. So that's all guys in this video. I hope you understood all the three sections: problem understanding, logic, and implementation. If you have any kind of doubt, you can write in the comment section. I am always there to help you. And if you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.